My name is Aproku Francis Etwahine, and I'm here with my group member Adjoini Madanso Asante. We are both in our second year of petrochemical engineering studies. Today, we are undertaking the project with the project title Vapor Liquid Equilibrium Prediction for binary mixtures using the Raoult law together with the Antoine's equation in Matlab. Now, at the end of this project, we will understand the science and the engineering behind the separation of crude oil or even the distillation of alcohol from water. So we will be given a set of mixtures, and then at a certain temperature and pressure, what will be first the type of mixture that you have. Is it going to be an ideal mixture, a non-ideal mixture? And if it's non-ideal, what type of non-ideal mixture is it? Is it an isotrope or non-isotrope mixture? We will also analyze the composition of the vapor, if there will be a vapor. What will be the composition of the individual components in the vapor? And finally, we will compare our mixture to an isotrope mixture, whether it will be very easy for us to separate this our mixture using simple distillation. So we will start by running our code. So after running it, we have a couple of binary mixtures here, so we will select one of them. So first, we are starting with the first mixture, which is ethanol and water. Now, at what temperature? We know that ethanol boils at 78 degrees. So we will take 78 degrees Celsius as our temperature at a pressure of 1 atm. Now, this is the outcome. At a pressure of 1 atm and 78 degrees Celsius, the type of mixture that we have is a non-ideal mixture. And indeed, if it's non-ideal mixture, what type of non-ideal mixture is it? Is it an isotrope or is non-isotropic? You will go and finalize that one on our graph. But now, let's look at the composition and the phase. So now we have X liquid here, we have Y vapor, and then we have the phase. Now the S liquid is the composition of the first component of the mixture. So here our first component is ethanol. So what's the composition of ethanol in our mixture? Now Y vapor is the composition of our first component, again ethanol, in the vapor after the given temperature and pressure. So let's start. If you start with 0% of ethanol in the mixture, that is, our mixture contains 100% water. Then you will not have any ethanol in the vapor, so the ethanol composition in the vapor will be 0. And what will be the phase? It's going to be liquid because the conditions given, which is 1 atm and 78 degrees Celsius, are not up to the saturation point of water. Hence, it will still exist as liquid. Now, what happens if we involve ethanol in our mixture? So, assuming our mixture contains 12% of ethanol and the remaining 88% of water, we will have 25% of ethanol, 25% of our vapor being ethanol. Now, when we compare these two numbers, we can see that the vapor component is higher than the liquid. This shows us that our first component, which is ethanol, is more volatile than water. Hence, it will evaporate easily, making it having an excess in the vapor. Now again, what will be the state or the phase? Now, at this temperature and pressure, we will have both liquid and gaseous or vapor state. Now, all this can be done for the individual composition. Let's assume it contains 50% of our component A. Again, our component A is ethanol. Then, our vapor will contain about 70% of ethanol and still exist as liquid and vapor state. Good. Now, what happens if our component contains 100% of ethanol? That is, all the components inside are ethanol. Then Since the conditions given, that the conditions that we have given are the saturation point of ethanol, we will have vapor. So the state will be vapor, and the vapor will contain 100% of ethanol. Now let's come to the analysis of the graph. Now on the analysis of the graph, we have this red line here and the blue line. Now the red line represents the isotropic nature of the solution, and then the blue line represents our actual solution. Now we can see that our blue line is not on the red line, it deviates from the red line. This tells us that indeed our mixture is non-ideal and at the same time non-isotropic. Good. Now, what you have done can be done for the remaining mixtures. So, assuming if one choose a different mixture, the person will have the composition and the person will have the phase and the graph to show whether it's an isotrope or not. If your blue line is lying directly on the red, then it should tell us that indeed our mixture is an isotrope. Now, to conclude this, we chose this project because it combines key areas in chemical engineering, including thermodynamics, process analysis, and computational modeling. Vapor liquid equilibrium is a fundamental topic that plays a major role in many industrial processes, making it both important and practical to study. Another reason for choosing this project is the opportunity to apply theoretical knowledge in a practical way. By developing a Matlab program, it has become easier to visualize and understand how different variables such as temperature, pressure, and composition affect systems behavior. Thank you very much for listening. We will be very glad to answer all your questions in the comment section. Thank you.